Hi everyone, myself Nithin Heraje, Assistant Professor, Department of Computer Science and Engineering, AJ Institute of Engineering and Technology, Mangaluru. In this video, I'm going to explain lab program 3 and 4 of computer graphics laboratory. So the lab program 3 is that it is draw a color cube and spin it using OpenGL transformation matrices. So if you look at this cube, in this there are see six faces over here in this cube, and here each endpoint or vertex is numbered. So this is numbered as 0, this is numbered as 3, this is numbered as 2, this is numbered as 1, and just look at this uh, color cube function. So if you look at this, you're going to call another function called polygon, and you're going to pass some values as parameters. So what are these values? If you just look at this 0, 3, 2, 1, see 0, 3, 2, 1, this is one phase of the cube. 0, 4, 7, 3, 0, 4, 7, 3. So this is another face of the cube. 5, 4, 0, 1, 5, 4, 0, 1. So this is one more face. 2, 3, 7, 6, another face. 1, 2, 6, 5, one more face. And last is 4, 5, 6, 7. So complete all the phases of the cube is completed. Okay, it has been constructed using the polygon. Now let's just look at this. See, there this is vertices is given with the two-dimensional array over here. Okay, so let me check. It is pair of 3 values, which is nothing but x value, y-axis value, and z-axis value. If you consider this cube, the center point of this cube is taken as the origin. So whatever, say suppose this is the center point over here, the left side whatever is there will be negative for x-axis, right side whatever is there it will be positive for x-axis, whatever above this center point is y positive, below the center point is y negative, and behind this center point, that is for 5, 6, 7 and all, it is z will be positive. uh, Front of this center point, that is 1, 2 and all, it will be z negative value. So let me just take this here. This is I can say this as uh, v of 0. Okay, and this 3 means each set of 3 values. Okay, so minus 1, minus 1, minus 1. So where this minus 1, minus 1, that is x value is minus 1, y value is minus 1, and z value is minus 1, and the position, that is index of this is v of that is vertices of 0. So if you look at this, this point is minus 1, minus 1, minus 1, because this is left side of this center point. If this is the center point, the left side below y is negative, left x is negative, front so z is also negative, minus 1, minus 1, minus 1. Let us take this now. Okay, the center point is here. uh, since left x is negative, up y positive, front z is negative. So it would be -1, 1, and -1. So let's check. So this is so this is 1, uh, -1, -1. Let us check which point is this. Okay, 1, -1, -1. So here if you just check what is 1 -1 -1, 1x is positive, so this 3. This point is uh, 1 -1 -1. Similarly, if you check it this, this would be uh, x is positive since it is right. This is the center point. X would be positive, y would be positive, and z would be negative. That is 1, 1, -1. Okay. Similarly, all the points are calculated, and you can write these points. So there won't be any issues for you to reach out all these points. So just to draw a cube like this, give the numbering like this, and start writing these values depending on the positions, and similarly construct these faces. Okay, so when you construct these faces, it will be all right. So uh, these two things are clear, and it is easy, I feel. And next is this polygon. So polygon is the method where you pass a, b, c, d value. Okay, and here if you look at this, there are color values. This color values you can give anything. So for every vertex there is one color value that has been given over here. So before drawing that vertex, you would go for the before drawing a face, you would go for a color. So vertices of a means a will have three values. These uh, three values over here. A is nothing but here it is, see this a. A means here it is 0. So this would be vertices of 0. Next b is vertices of 3. The second parameter is 3, third parameter is 2, and the fourth parameter is 1. So it will construct this 0, 3, 2, 1. Okay. So similarly, it is going to construct different faces. Okay. So once this polygon is constructed, next again this, that is 0, 4, 7, 3 will be constructed, and so on. All right. Uh, so I hope you are clear with this color cube, how to create a color cube. So color cube will call polygon, and polygon will use vertices, these vertices. Okay, vertices, and then the colors for different polygons. All right. So here there are two initializations. So there is a theta, which is a single dimensional array having three values. So this is theta of 0, which is with respect to x-axis. Theta of 1 is with respect to y-axis, and theta of 2 is with respect to z-axis. So axis, we will use theta of axis. So axis is initialized with the 2. That means it is theta of 2. That means this one, which is z-axis. Okay. So initial value of axis is set to 2. I will just go to the main function now. So these things we have already discussed, and you are clear with that. So reshape function. So when you resize the window, you are going to use the reshape function. Okay, and this we have already discussed about this reshape function. Okay. Next is that display function. Let's see what is there in the display function. Uh, Before that, yeah, we'll go to the display function. So look at this. So this is the display function. These things are clear with you by now. Next, there is a GL rotate function that has been used, and this GL rotate function uses these four parameters. Okay, that is first parameter is nothing but the angle theta. Okay, for what angle the particular rotation has to be made, and this 100 it is nothing but it's. So these are the three values which says x-axis, y-axis, z-axis. So whichever is 1, that means the rotation will be with respect to, so this if you see, x-axis is set to 1, that means the rotation takes place with respect to x-axis. If y value is 1, then rotation will take place with respect to y-axis, and this one is rotation takes place with respect to z-axis. I've already mentioned how the rotation will take place if it is x-axis, if it is y-axis, if it is z-axis in the earlier program, that is rotating uh, the triangle. Okay, so then after that you're passing a rotate function. So rotate function will see whichever angle it is, whatever the angle value, that is the theta value, will be passed on to this, and it takes the rotation. And here color cube function is passed, where the color cube, that is this cube, will be drawn, and we have already discussed about it. Okay, next if you look at the main function, there is an idle function that is used, that is glut idle function. You know where what idle function is responsible to do. So when there is no event happening, or no action happening, it simply executes the function that is there inside the idle function. So inside the idle function there is a spin cube function. So spin cube function will be performing. Okay, so here in the spin cube, if you look at theta of axis, whichever axis value is set. So before that I would just go to this here void mouse function. So mouse function, if you look at this, if you click on the left button and the state is down, the axis is set to 0, which means it is for x-axis rotation. 0 is for x-axis rotation, which we already discussed. And if the middle button is pressed, the axis value is set to 1, where the rotation takes place with respect to y-axis. And the last one, when you click on the right button, that is right button is clicked down, z-axis will be set, that is axis equal to 2, means with respect to z it is. So coming to spin cube, it just if you look at this, whatever axis currently it is there, so for that it increments the theta value by 1. Okay, and if theta value exceeds 360, you are just going to set it to 360. So theta sorry, not set to 360, set it to 0. So from 360 the value will be set to 0, and again it restarts the process. Okay, so this is about color cube rotation. Okay, that is, you are just going to spin the cube. And next program is the fourth lab program, that is here, draw a color cube and allow the user to move the camera suitably to experiment with the perspective viewing. So this is with respect to the perspective viewing, and the user need to move the camera. So when you say there is a user or the viewer, so when you have a viewing position or you have a camera viewing, then it is with respect to GL look at. which we already discussed. Okay, so this program is almost similar to the previous program, that is program number 3. The construction of color cube and spinning of the color cube, everything would be same, except here the camera position will be changed. So based on the camera position, the cube whatever view will be different. Okay, so this again, these vertices, how you got it is same what I explained in the previous program, and any color you can set. Okay, next you have how you got these different faces, correct? And then what is the use of this? How do you construct a polygon? So everything explained. And if you look at this here, this line was there initially, correct, in the previous program, and even this was there in the previous program, theta, which is here with respect to x, y, and z. So initially the axis is set to 2, that means initially it is the rotation is with respect to z axis. And one extra thing added over here is the viewer. Okay, this is viewer is a single dimension wherein 3 values have been passed, and this, if you look at it, is 0, 0, 5. So again, this is about x-axis, first value. The second value is about y-axis, and the third value is about z-axis. Okay, next, just look at this display function over here. Display function, see, this is that one new thing that is there compared to the previous program, that in the display function you need to place the viewer, okay, and specify the viewer position. If you look at this, there are 9 parameters that are passed to GLU look at. So we'll see what are those 9 parameters. Okay, so if you look at this look at function, this is the camera position, this is your color cube, and this is the center point of the cube, or I will say the origin. So let us see what are the first 3 parameters. If you look at this GLU look at, these are the first 3 parameter, I, x, y, z. So this position from where the camera is going to view, or your eye position, we can say. Okay, so this position where the camera is placed, so which is I, x, y, z, and the next 3 parameters are where the camera is looking at. So the camera is looking at this particular point, that is origin of the cube. Okay, and in our lab program example, it would be 0, 0, 0. The center point of the cube is 0, 0, 0. So x, y, and z value would be 0 for this particular position. Okay, the reference position. And next one is that up vector. So this is the up vector. Okay, so that would have some different values. So if you look at this now, first 3 positions are the camera position. Viewer 0, 1, 2. Okay, viewer 0 means here that is x value is 0. Here the second one, y value is also 0, and the third one is the z value. So z value is 5, it is given. Okay, next this 3 parameter x, y, z is that where the camera is looking at. So camera is looking at the origin or center point of the cube, where all x, y, and z values are 0. Next 3 are the up vectors. So this up vector, x and y values are x and z values are 0, and y value is set to 1. So this is one line addition compared to the previous program. Okay, rest all are same. Next, coming to the mouse function over here. So similarly, same as that before. Left is for X-axis rotation, right is for Y-axis rotation, and the middle is for Z-axis rotation in this. So you have given the different axis values being set, where when left mouse button is clicked, the right button is clicked, then center button is clicked. So here the value of theta is incremented by 2, okay, and it keeps checking if theta is until theta is less than 360, nothing is going to happen. If theta reaches 360, then what has to be done is theta of axis is uh, minus, you need to reduce it to 0. So theta of axis will be made the value as 0. All right. So next, if you look at this, so void keys, we have three different keys, x, y, and z. The lowercase x means you are going to reduce the x value. Uppercase x means so you are going to increment the x value. Similarly with y and z. Okay, so you know that viewer 0 is for x-axis, viewer of 1 is for y-axis, and viewer of 2 is for z-axis. So as we meant, lowercase x will reduce the value of x, uppercase x will increment the value of x by 1 unit. Similarly with y, and similarly with z. Okay, so that is with respect to key, and this is that addition compared to the previous program. And of course, yes, here it has been asked for perspective weaving. So GL frustum is used in the my reshape function, where there we had used GL ortho, which is a parallel view. So this is the perspective weave. Okay, so that's why frustum has been used. And coming to the main function, um, there is no much change over here. The keyboard has been used, so initialize or register the keyboard function, and keys is the function name. Mouse function similar as that of the previous one. Enable depth test, this is to detect, this is for visible surface detection. Okay, uh, yeah, rest it is same as that of the previous program. There is no difficulty, both are same, uh, except a few changes. Here we are using this keyboard function, and you are going to enable the depth test, and this GL frustum has been changed because perspective weaving has been asked. This would be an extra line of code which is meant for changing the camera position, that is it might be with respect to x, y, or z axis, and this remains same as that of the previous one. This complete mouse function will remain same as the previous one, and this display also remains same, except this one line where you add a GLU look at function, okay, which specifies the camera or the viewer position. Rest, okay, this initialization is one more additional line compared to the previous program. Rest, it is exactly same as that of lab program 3, and a very easy program though. Okay, so you might be worried how to remember all these points, so I've already given you the tip. Take center point as the origin, so towards the left of it would be, you know, x-axis would be negative, towards the right the x-axis would be positive. with respect to center point. Again, above that y would be positive, below that y would be negative, and the front of this point, that is 0 1 2 3, would be negative, and the back side of the center point would be positive. That is, z axis would be positive. So based on that, you can construct these values, and then similarly construct the polygon this way. All right. Hope you have understood these two programs. Okay. Thanks for watching this video. If you like, please click on the like button. Thank you so much. Thanks for watching.